Good morning to everyone watching the channel. This is Brent with Lykins Motorsports. This is one of my messy workbenches. Dad always used to say that when you start to work on something, you might as well just drag out every single tool you have and lay it out, because you're gonna make a mess of things. So that's kind of what I've got going on here. It's just a complete mess. But what we're doing today is we're going to be assembling a set of CHI heads. These are the heads for our 470 cubic inch cleaver that we started a couple years ago. So we're just progressing at the customer's rate, and it is a slow process, but we're getting through some things. So at the time that we ordered these heads, the 208cc heads were not available. These are 225s. The 208s actually respond to port work better than the 225s. The 208s, it's not uncommon to see them at 390 CFM. These are around 350, 360. They'll still make a lot of horsepower. The heads these are my absolute favorite Cleveland head. They are just top notch. They make tremendous horsepower. I did a 434 cubic inch bracket motor several years ago with some ported 208cc heads. 14-to-1 single carburetor intake, nothing really fancy, and it made almost 780 horsepower at just 700 or 7,000 RPM. So just a tremendous potential from these heads. When we port these, we don't even do any changes to the port opening itself. You can see that this is the original CHI port. It still has the CNC marks there. We didn't do anything to change that. All of the work is done down inside the port, around the throat, the bowl, short turn radius, that sort of thing. So it doesn't take much to make these things turn up. These are called the 3V heads, and CHI kind of called them that because they are kind of a hybrid head. They have a smaller port opening like a 2V factory Cleveland head, but they perform and flow like a 4V factory head, and then some. So these are kind of middle ground cylinder heads in terms of where the intake port is, the size, the volume, that sort of thing. So when we port these, the port volume goes up generally anywhere between 240 and 260 cc's. So really not a big fat head in terms of port volume, but they just work really well. We're using some Ferrea valves, two 190 and a 165, so it just doesn't take much valve to get these things to work. I had written on the valves 50-degree seat. We're using a little bit of cam for this engine, so we bumped the seat angle up to handle that more effectively. The intake side, we're using a 1/8 rocker ratio on the intake side, and we're at 780 gross lift, 20,000 slash, so we're going to be at 760 net lift. On the exhaust side, we're using a 1/7 ratio with our T&D rockers, and we're at 730 at the valve on the exhaust side. So for the top end parts, we went to PAC for the valve springs, for the retainers, the spring locators, and the locks. So this is the valve spring that we're going to be using. Look how small this dude is. This is where technology is heading. This is a solid roller spring, and after I've chucked it up in the spring pressure tester, these are about 270 on the seat and about 830 open. These are 1/300 diameter. Very light, very small. We're going to be using some titanium retainers with these guys. Pack retainers, very light, very small. So anytime that you can lighten up while keeping the rigidity of your valve train, it's going to be a plus for you. That does not include the push rod side. On the push rod side, you always focus on rigidity. I never focus on weight because that's a sprung weight. So rigidity counts there. Spring locators from Pack as well. The heads come with bronze valve guides, obviously a 530 seal OD right here, so we can use some Manley Viton valve seals. T&D shaft mounted rockers, so they have a common bar that bolts to these, and then they have little paired rocker arms that work with them. So we're going to get hopping on this. What I've done so far is taken a preliminary install height measurement, and then I've checked all my valve springs to make sure that they're all right in there with each other. And also I bound them all, coil bound, let me start that sentence over again, coil bound them all up. And when we do that, you basically compress the spring until it makes a solid out of itself. And that's basically your coil bind dimension, and you want to stay over that, obviously. How far you stay over that is determined by the valve spring brand, what the manufacturer's specs are, RPM you're going to be reaching, that sort of thing. Generally, you want to start out 50 or 60 thousandths to coil bind is where a lot of us tend to aim, but you can open that up a little bit if the spring manufacturer and the RPM say that it's okay. So we're, I think, about 80 or 90 on these guys. But we went through and checked all the valve springs, recorded all the coil bind dimensions, recorded valve spring loads, and I'm just at a point where I can go through and start mapping each and every install height. If you notice, I already have the valve seals on these two guys, because it's very critical on Cleveland stuff that you check the retainer to seal dimension, and especially on the exhaust valve. What I had to do on this is the seal will still bottom out on the guide, so it's not raised up. But what I had to do on the exhaust side was go to a plus 50 lock, and then use a shim underneath the locator. So what I've done is I've essentially moved the retainer up in relation to the valve seal and the valve guide, but I shimmed the spring back up so I don't lose any of my spring load. So just keep a close eyeball on retainer to seal clearances. And what happens is when you put your locks in here and you pull your valve up, you want to check with some calipers and make sure that this distance is greater than your valve lift distance. You will see different guys use different standards for that. In my own head, I don't like going any closer than 40 thousandths. That has worked for me over the past 15 years, so that's my go-to as a don't exceed that dimension. So I'm going to check these one more time, and then we're going to go through, map out all of our install heights, and get going. Another thing that we're having to worry about is our spring mic. So some of these retainers, let me show you some of my other spring mics that I have. You kind of have to watch, because some of these small retainers are such that they don't fit your spring mics very well. So you can see this one, I would not trust it at all. This one's kind of the same way. That one actually fits down inside. This one sits down on top, but it sits down it doesn't sit down enough. So that step still sticks down. What I'm doing is I measured that step. It's exactly 100 thousandths. So I can check my install height measurement, then I can add 100 thousandths to it, and that will give me a solidified measurement to go off of. So different heads, different techniques, different tools that we have to use, but we just get the job done. So going to check retainer to seal clearance, and then we can get going. Okay, so we're going to check this intake valve first. We're going to put our locks on here. Then pull up on our retainer. So you can see this distance here is retainer to seal clearance. We're going to take our calipers and measure. Got 820. So we're looking at 760 at the valve and 820 retainer to seal clearance. So we're good with 60 thousandths intake retainer to seal clearance after the valve lift. All right, we're going to check our exhaust side, and again we check this with different valve springs or different valve locks. So we are at, sorry, I'm in the way, 770. So we're right at that limit that I have imposed on myself. So the valve lift will be 730, and with 770 retainer to seal clearance, we have 40 thousandths clearance. So I am comfortable with that, and I've ran that in the past. So we're going to run it here. I'm going to check it on every single one just to make sure that there are no situations where something creeps up on me that I don't see. Okay, well, we went through and got all of our install heights. In certain applications, it's normal to get a different install height for exhaust valve versus the intake valve. So all of our intake valves, 1832, 1822, 37, 31, so they're all in there real tight together. Exhaust 792, 792, 792, 798, so they're all in there tight together. What I'm going to do now is take the valves out, put our valve seals on, put the valves back in, and then as you see, I've laid out the retainers and locks that I measured with, because there can sometimes be a couple of thousandths difference between them. And I just basically, out of OCD and all that stuff, I just keep everything in order. But we'll go through and check our retainer to seal clearance on every single one. All right, we're doing valve seal installation. On these particular seals, you can just use a 1/2 inch socket and push them down. And as I've told you in the past, you shouldn't have to hammer these things on. It takes a little bit of force to get them on, but you shouldn't have to damage the seals or anything to get those things on. All right, so we got all of our clearances checked, and decided not to do that on camera. It's just monotonous and tedious. Got all of our springs laid out, and now it's just a point of just putting everything back together. Well, this is something. I went to put these heads together, and you know, you grab a spring, you put it on there, and put your retainer and everything on. I was like, I wonder why that spring won't go down over. So took the spring apart. The spring will not fit over those valve seals. I did not see that coming. All right, so we got our head taken back apart, and what I decided to do was to use these small OD Valvetrain, oh my goodness, Valvetrain valve seals. What you notice though is that they don't have a lip to drive them on with, so I had to take a cutter and trim just a little bit off the valve guides, and then that way I can put them on there and set them on with a dead blow hammer. But This should put us back in business, and I believe that these are just a little bit shorter than the other ones, so that'll probably gain us some retainer to seal clearance as well. So give me a minute, let me get back to where I was, and then we'll put these heads together. All right, we have one assembled cylinder head, and it's time to hop over to the other one and cross our fingers that there are no hidden surprises waiting for us there. But just a really nice looking assembled head. You would never guess that these little springs were as beefy as what they are, but technology is slowly moving towards lighter and smaller parts for Valvetrain. I've personally used, so when you would think of a pulling truck engine turning 9,000, 9,500, you know, spring loads of 400 seat and 1,300 pounds open, you would think, oh, I need an inch 650 triple spring to do that. The springs that I use for those applications are just 1.5 inches in diameter, so very small, very lightweight retainers and locks and everything to go with it. But I'll get this other cylinder head going, and I'll catch back up with you here in a few minutes. All right, so we're starting on the other head, and one piece of advice I'll give is to treat it like you have just seen both pairs of heads and you have no clue what's going on. Sometimes you'll get cylinder heads that will set up exactly like you know, each other. Sometimes you have to adjust your spring height a little bit from one to the other. So I guess what I'm saying is, don't assume that you can roll through with the same shims and everything on both heads. Treat them both individually. All right, so all of our install heights pretty much came in exactly the same as the other head, so we're good to go. I'm not going to make you sit here and watch me put this other head together. It's exactly the same as the other one. From a few months back, I already got chamber volume and everything on it, so we will get these heads assembled and bagged up and ready for the next step on this engine. Thank you guys very much for watching and hanging in there with me. There's all kinds of little bumps in the road that you run into when you're putting custom engines together, and you just got to know how to what options you have and use your experience to pick the right one. Thank you all for watching. Hope you're having a good week. Hope you have a good weekend. Talk to you soon.